So we have a cluster, be it in the cloud or be it on your own machines or your on-premise machines. Let's continue with the second part to get some application running. And the second part is basically to get something consume the database and start using it. That said, I will start with hold your horses, cowboy, because before moving to an application, really, we need to think a little bit about the data model. So there are some rules of thumb that you basically need to think about. The first thing that I already mentioned is replication factor. So you always need to basically adjust the replication factor to fit your use case and to fit your architecture. Ideally, we by default suggest to use replication factor 3 and a network topology. And you have to be basically, you can populate the data model with the ScyllaDB. I'm showing some example commands on the top of the page. But you still have to think about the data model and be diligent about how you select your primary keys and your clustering keys. The clustering keys will give the ordering of the partition, but basically with the clustering key, you also add the rows to a certain primary key. So this influences its size. And of course, basically, the more primary keys you have, like the better the data is distributed amongst the CPUs, and you don't want to stick everything into your single primary key. You want to basically spread your data all over like multiple primary keys, and ideally not over many clustering keys because you'll get big partitions. How would it translate into our demo that we will show today? So I mentioned that we want to have the replication factor 3. So that's how you write it here. I also mentioned that we want to use the network topology strategy. I would like to emphasize this network topology strategy on this slide. It's very, very important because most of the people, when they see examples, they just use the simple strategy and never use simple strategy. Like I even suggest to use network topology strategy if you're going to test in your local environment. I think it's always better. Because if you do then any change to the topology of the cluster or change basically like how many nodes you have per rack or something, then you automatically get your data adjusted and you will see it immediately in the development as well. What is tricky in the development is the replication factor, because usually the developers, they don't start 3 nodes at least. They just start 1 node, and with 1 node, it's very hard to achieve replication factor 3. So if you have just 1 node, go only for replication factor 1. And of course, if you have 2 nodes, you need to go to replication factor 2. And that basically is the only problem that you might see when using this setting for the key space. Here I have a table that we will use today. The application that I will present is basically an application that collects stocks. So there will be like a symbol of the stock. There will be a date when the stock value was gathered, and there is a value of the stock, like what is the price or the current price at that date. I mentioned that it's very important to pick a correct primary key. So if you think about my primary key, it's not really ideal, but it's still, I think, good enough because it's like the symbol of the stock. And what Scylla is doing, Scylla is using murmur tree hash. And this murmur tree hash is then basically translated to a token. And this should give you like a good enough distribution of those symbols amongst the CPUs in your cluster. What is interesting here in my design, and it's basically, it's a flow, and it's a design. It's also a good design if you think about it, but I'll explain it on the next slide. I'm using date as the clustering key. And if you know about how this works, then you might tell me, oh, you have a mistake there, Lubos. And yes, I might have a mistake, but I'm trying to kind of think about the cardinality of the date here. So my plan is to basically have this date limited using TTLs. So that's why the single partition for a single symbol will not grow that much. If you want to basically have smaller partitions, then you would need to have like a composite key, but I will not show composite key during this demo. I will leave it up to you. You can look at the composite keys in our documentation. It's very good to understand it. And I think it's especially good to understand them for the time series data. And this is a time series data because we will measure the price of the stock every day. So, because we will have a stock application that will collect the prices of the stocks over 1 year, this is basically where the second part of the data modeling comes in. So you need to think about, like, I don't really want to have big partitions, despite that the row is not that big because it's only like symbol, date, and value. You still don't want to have it like, I don't know, 100,000 of records per partition there. So that's why I'm continuing with the data model in a way that I will use the TTL for 1 year. So you can set up a TTL on the table. How to set it up, it's not on the slide, but I will just assume that you will look up how this can be done in the documentation. But I'm showing something else that is more important here, and this is basically the strategy about time series data. So it's a good practice or a best practice to go and schedule your data to be within 12 to 13 windows. And this basically will split your data into 13 like buckets, if you can call them like that. And then basically, if you will be looking up some older data or some historical data, you'll just need to scan or go over only the appropriate window. Like Scylla will know that this data belongs to this certain window, and it will just go there. This window will be already like compacted for you. And of course, basically, when this window comes to a comes closer to the TTL or goes over the TTL, Scylla will immediately know, okay, this window is already TTL, and it will throw away. So in this case, I will have, in the worst case, 13 or 14, or actually 12. So I will have 13 windows at most, because there will be at most like one old window that will eventually TTL. This basically translates to my window size, because if it's 1 year, so I need to divide 365 days by 12, and this roughly comes to 31 days. So my window is 31 days. While setting that, you need to consider also one more thing. So once the window is closed, it's not really good to go and modify this window. So you should also try to plan your time series data to not overwrite historical data or not go outside of the window. So if you will like backpopulate some data within the window, it's okay. Compactions will take care of it. But if you will start doing that for older windows, then you might get into troubles, because those writes will overlap to Windows, and it might come with some latency punishment, and you don't want that. So I have a question there. How big will be the partition if we collect prices daily? And that's actually very easy to do. Like you just need to divide 365 by 31, and you will see like how many records will be scanned at one time. The partition itself will be 365 rows at maximum, but what still I will need to scan will be inside one window. Oh, by the way, before I go further, if you didn't catch most of the stuff I said, it's all well documented. So you can look at the documentation about compaction strategies, and you can look at other compaction strategies as well at the same time. Time window is not the default one. The default strategy is either size tiered or ICS, incremental. So you can look at the time window and the others later and compare them what fits for you.